We will start with second module. Second module of wireless and mobile communication, it deals with the propagation models. You know that electromagnetic wave is propagating in free space from the sender to the receiver or from the transmitter to the receiver. And it will make use of line of sight propagation or non-line of sight propagation. What do you mean by line of sight and non-line of sight propagation? If there is no hindrance or obstacles in between the transmitter and the receiver, if the two antennas can see to each other without any obstacles in between, then the electromagnetic waves that is transmitting from the transmitter will get into the receiver without any reflection. Okay, so direct transmission between the transmitter and the receiver will happen. That is what is called line of sight. When we go for an urban area and all, we will have large buildings that is acting as obstacles between the transmitter antenna and the receiver antenna. In that case, we can call it as a non-line of sight communication. The performance of this entire wireless communication system, it is going to be affected because of these obstacles in between. Because when you have multiple number of obstacles that is coming in between the path of the transmitter and the receiver, it will add different multipath propagation. Okay, suppose one radio wave is transmitting directly from the transmitter to receiver. Second wave, what will happen is the second wave will touch the obstacle or it will impinge on the obstacle and then it will be reflecting back to the receiver. In that case, we'll have two paths. If there is more number of obstacles means you will be perceiving more number of reflections or diffractions or scattering, whatever it may be. So these reflections, diffractions and scatterings, it depends upon the kind of obstacles, the size of the obstacles, the shape of the obstacles, okay, in between the communication path. So all these contributes different multipath propagation paths, okay, multipath propagation mechanism. Since one electromagnetic wave is not taking the same path from transmitter to receiver, it is taking multiple paths. What does it offers? It will offer multipath fading. Means ultimately, when the signal receives at the destination, its strength is going to be deteriorated. Okay, drastically, the signal strength is going to decrease because of this multipath fading. What do you mean by multipath? Transmitter and the receiver is connecting, or they are connected in between. They are having a large number of obstacles in between. As a result, the transmitted wave is reaching to the receiver through multiple number of paths, not through single path. It is coming through multiple number of paths. As a result, we will have a severe number of obstacles and fading will occur. Okay, fading in the sense that finally the received signal strength is going to be decreased because of this fading or because of this obstacles in between. Now, the main speciality of this fading or the main reason of this fading, as I told you, it is one reason is that the obstacle. Second reason is that the channels are random and the time varying. That is the channel's feature. The characteristics of the feature will be randomly varying or continuously varying with respect to time. So these radio channels or the characteristics of these channels, we need to analyze it carefully for each and every instant of time so that we can model the channel and we'll have a feasible or the desirable signals at the receiver. Because we can't remove the obstacles in between, right? Obstacles will be there. The channel's characteristics will change randomly with respect to time. All these aspects we need to consider accordingly, and we will be able and we should be able to deliver, or we should be able to get the exact message or exact electromagnetic signal whatever we are intended to get at the receiver. So that is nothing but it should be done by the designer's point of view. The communication system designer has to do that. Can't tell that the transmitter and receiver should always have a line of sight communication in between. We can't ensure that. We will have a number of obstacles that is contributing towards multipath fading effects. So you see that the electromagnetic waves, it is propagating through the space and it is having two components. One is electric field and one is magnetic field, which will be oscillating perpendicular to each other, isn't it? It is antenna who is converting any kind of signal into electromagnetic wave. If you have a transmitting station or a broadcasting studio like a TV transmitter, then that particular antenna is converting electrical signal into an electromagnetic signal. You will have a combination of picture and audio, that is nothing but your electrical. This electrical signal will be converted to electromagnetic signal by the transmitting antenna, and at the receiver, that is at your home, you are having another antenna, nothing but a dish antenna or direct to home service, DTH or whatever it may be. That kind of antenna will be converting the electromagnetic signal back into electrical signal. So through the free space, we are going to send the information or message in the form of electromagnetic waves, where you will be having two components. One is electric field and another one is magnetic field, which will be oscillating in a perpendicular manner to each other. Okay, so by using these kinds of antenna, we will be able to transmit and receive the electromagnetic waves. Okay, either we can send microwaves or we can send infrared, visible light spectrum or radio waves, but the most commonly used will be the radio waves, which will have a larger band of frequencies. So for almost all communication applications, we will be making use of radio waves. For distant communication and all, we will be making use of radio frequency waves for the communication. So I repeat, in this module, we are discussing about the propagation mechanisms and the propagation models. Models in the sense, we are making the channels, or we are analyzing the channels characteristics, how the characteristics of the channels are varying with respect to time, and accordingly we are modeling the propagation mechanism so that we will get the desired output, provided the input is transmitting in a possible or in a desirable manner. So after transmitting your input message or input electromagnetic wave from the transmitter, we would like to model the channel accordingly, and we will deliver or will take the output at the receiver. The main properties of the radio waves are they are very easy to generate. And when you are using radio waves for communication, instead of using visible spectrum or instead of using infrared, why you are using radio waves for the communication? The main property behind radio waves is that they can travel long distance. So for all the long distance communication, we'll be making use of radio waves, and also they can penetrate building and obstacles. In urban environment and all, we'll have a tower at the transmitter and a tower at the receiver. So even though there is no line of sight link between this transmitter and receiver, and there is n number of obstacles in between, still we are capable of receiving the electromagnetic signal in a sufficient strength, isn't it? So how is it happen? How this makes happen? Because of this radio waves. These radio waves are able to penetrate through the obstacles and buildings, and ultimately they are getting at the receiver point of at the receiver end by using multiple paths, not by same path, because there is no line of sight communication. If there is a line of sight link, means there will be a direct transmission from the transmitting antenna to the receiving antenna, because they can see to each other, isn't it? But if there is some obstacles in between, or it's like some buildings are there, means severe diffraction or severe scattering or reflection will take place. So that will yield in a multipath propagation. Multipath means the transmitted electromagnetic wave is now propagating through different paths, and then ultimately it is getting received at the receiver. So what happens is that the signal strength will drastically reduce. So we can't avoid this. But the thing is that if we carefully model the channel, then we will be able to increase the signal strength in an appreciable way. So another property is that the radio waves can be used for indoor as well as outdoor coverage. That is why even if your cell phone is inside the home or outside the home, if it is an outdoor also, you are getting the coverage, or you are getting the range or signal. And omnidirectional, can travel in all directions. That is, radio waves are omnidirectional, means they'll be able to travel in all directions. It is not focused to a single direction. Okay, so it can travel in all 360-degree directions. And when you increase high frequency radio waves, or if the frequency of radio waves are being increased, or if you're using the high frequency domain of the radio waves, then we can use it for the long distance communication, especially for the when we use parabolic antennas and all. When the main speciality of parabolic antennas are that they are having omnidirectional concepts. Okay, means they will be able to provide coverage uniformly in all directions. Now, there are some applications or some parabolic antennas or like horn antennas and all. There are some other antennas, horn antennas. Then you will have Yagi-Uda antennas. That is the old TV and television and Doordarshan antennas. They are called as Yagi-Uda antennas. So the main drawback of such antennas are that they are highly focused. Okay, means their radiations will be focused only to one particular direction. That is why in the earlier times we used to tilt those antennas after having a heavy rainfall or wind, because the direction of the antennas will be changed, and frequently we need to tilt those antennas in order to get the directions. So there are such sort of antennas which will be focused, and like some parabolic antennas are there which is having high directivity in all radiations, I mean all directions in common way. Okay, so we can, depending upon the applications, we are free to choose any kind of antenna, whether it is a directional antenna or whether it is an omnidirectional antenna. But the directivity can be narrowed by increasing the frequency. At high frequencies, like greater than 100 megahertz and all, we'll be able to select some specific parabolic antennas which will be able to focus the radiations in a desired directions alone. Clear? So these are some of the basic properties of the radio waves. They are easy to generate. They can travel for long distances. They have the ability to penetrate into buildings, and both indoor and outdoor coverages we have with the radio waves, and they're omnidirectional, means they will be having uniform coverage in 360-degree, and in certain cases also we'll be able to focus the radiations to an intended receivers only if we use a very high frequency greater than 100 megahertz. Now, other properties are, it just behaves as light. Okay, in some situations, it behaves more like light at high frequencies. Light means, behaves like light means it follows direct path. It may be absorbed by rain, and it is difficulty in passing obstacles. Even though I can say that radio waves can penetrate through obstacles, but in certain situations, we will have some diffractions, scattering or reflections. That is, it is it gets difficulty in passing through the obstacle. That is, after impinging to the obstacle, it will get reflected back to the same medium, or it will be transmitting into the second medium. Like that is what is known as refraction. So all these happens with respect to light, isn't it? So we can say that in certain cases, this radio waves will behave like light also. That is for high frequency, isn't okay? That is greater than 100 megahertz. But if we are using the low frequency radio waves, they are easy to pass the obstacles. That is why I told you high frequency radio waves are more focused to a particular direction. So they can't penetrate through the buildings or obstacles. But low frequency radio waves can pass through the obstacles, and power falls off sharply with the distance from the source. That is, if they are traveling more distance from the source or the sender, okay, then the power received at the receiver point will be drastically decreasing. Means the separation between the transmitter and the receiver is very large. It means that the power delivered to the receiver will be very less. So that is what is the property of low frequency radio waves, which can pass through the obstacles. But what happens when it passes through the obstacles severely? We are going to degrade the power, or we are getting a very less power at the receiver's end. Okay, we can't say that obstacles should not be there in between the path. Obstacles will be there, but it is confined to us to use proper frequencies such that these signals will penetrate through those obstacles, or they should reflect or diffract from the obstacles, and ultimately they will be reaching at the receiver. But what will happen if they reach at the receiver? Severely, the power is going to decrease. That's what is called fading. Understood? Whatever the power which you are going to transmit at the transmitter, you are not getting at the receiver. Because of the fading, your power is going to decrease. This is because of the low frequency radio waves that can pass the obstacles, but even though they pass through the obstacles, but severe power degradation will happen. And another property is that they are subjected to interference. Means if other radio waves of different frequencies or close frequencies or same frequencies are traveling through the same channel or adjacent channel, then there is a high chance of interference, as we discussed in the first module, like per channel and adjacent channel interference. Okay, if you are sending the radio waves of same frequency in the same channel, of course there will be interference. And still, if you are sending two neighboring frequencies in two closed cells or two neighboring cells, then there will be always there's a high chance of adjacent channel interference. Also, co-channel interference, you know, it is nothing but the interference between two radio waves or interference between two, calls that are having or that are sharing same sets of channels, even though they are distantly apart from each other, but still there will be some sort of interference. So we have to carefully place these cells in such a way that interference will be minimum. That is what is the concept of co-channel cells, as we discussed earlier. So these are some of the properties of the radio waves. Now, what is the use of studying this propagation models? I told you in this module, we will be discussing about propagation models. The statistical modeling is usually done based on the data measurements made specifically for the communication system and the spectrum. Means based upon the data that we have collected. Okay, I told that the channel's parameters will be always continuously changing with respect to time. It is unpredictable. Maybe it is a statistical data in some point of view, but in certain aspects it can be non-statistical also. That is randomly it gets varied. Even though it is a random behavior, but still by using some trial and error procedures, we will be able to model the channel successfully so that we will get the intended signals of the receiver. So the main tools which are required to model the channels are, the first one, the average signal strength at a given distance from the transmitter. That is, transmitter will be sending some sort of signals and those signals will be received at the receiver. And we are going to measure the signal strength at the receiver. And the receiver is at a particular distance from the transmitter, isn't it? When the distance increases, what will happen? The signal strength will decrease. So we are there to predict the signal strength at a given distance away from the transmitter by using different models. Clear? So what is the use of the propagation models? Propagation model is used to predict certain data with respect to the channel's behavior. So we are there to find the power delivered at the receiver side, where receiver is at a distance of d away from the transmitter. So predicting the average signal strength at a given distance away from the transmitter, that is one tool. Second, how this signal strength is getting varied, okay, in close spatial proximity to a particular location. That is, with respect to the locations around the transmitter, how the signal is getting varied. You have a locus of points around the transmitting antenna. If you join those locus of points, maybe you will get a sphere, or maybe you will get a hexagon, or maybe you will get a circle. Okay, so in this particular pattern, how the signal strength is getting varied. So there should be a graph, isn't it? That is, with respect to the locations, like the signal is getting varied. So like that we can predict. So these predictions are done by using these propagation models. There are mainly two propagation model. One is large scale propagation model and second one is small scale propagation model. This I'll continue in the next class. Afternoon I will have 1 hour, so kindly join. Any doubts? So this is an introductory class for second module. So basically in this module we are trying to deal with the propagation model. I repeat, the propagation model in the sense we are trying to model the channel, study different data. The main data is nothing but the signal strength and power received at the receiver from the transmitter. From the transmitter, you have sent a signal after a d distance because the wave is propagating through the space, isn't it? So after a d distance, we are there to monitor the received power. Okay, so that received power can be carefully determined by using some models. So there we are having large scale propagation models and small scale propagation models that depends upon the channel's characteristics. We can't predict the behavior of the channel. The behavior of the channel will vary according to the natural phenomena also, like temperature, pressure, humidity. Then it will depend upon the rainfall, climatic conditions. Okay, then the location. So everything it matters. The environment, like urban or rural. So in everything, this all these parameters or surrounding parameters is going to determine our channel's model. So practically we will analyze different models, and based upon those models we are there to find the received power at the receiver's end, which is spaced at a distance d apart from the transmitter. That is the use of studying these propagation models. Okay, we'll continue in the next class. Thank you all.